Hello and welcome back to another video lesson. We are talking about this standard called 7.E.E.A.1. And this is 7th grade equations and equalities, equations and equalities. Oh man, it's going to bother me. Now I have to look it up. 7th grade, it's equations and expressions and equations. That's what it is. Expressions and equations. Cluster A, standard number 1. Yeah, I had to memorize all these things, becoming a teacher and all these fun things. But yeah, expressions and equations, or equations and expressions, one or the other. All right, let's get started. So we are going to be doing some like arithmetic and math and adding and subtracting and all the good things. So we want to see what the following is here for, let me get orange here. Select the expression equivalent to what this is. So we have 4x, and it has parentheses, but there's nothing we need to do in parentheses, so I'm going to get rid of those, plus negative 2x plus 4. Now, I could easily get rid of this positive because a positive and a negative that are right next to each other really just mean a negative. And the thing is that this positive is being distributed to both sides. So let me just do that one more time with the parentheses. Plus 3 plus negative 2x plus 4. This sign right here is being multiplied here and here. So what is a positive and a negative equal? Well, that's going to be a negative. So negative 2x. What's a positive times its positive? That's going to be a positive 4. And you're saying, how do you multiply a positive number? Well, just imagine there's an imaginary 1 here then, because positive 1 times negative 2x is still a negative 2x. A positive 1 times positive 4 is still positive 4. Excuse me. And then we have 4x plus 3, so I'm going to add 4x plus 3. So all you need to do, you have a 4x here, and you have a negative 2x. That's going to be a 2x. And then I'm going to use red. We have a positive 3 and a positive 4. That's going to be a positive 7. So that is going to be our correct answer. All right, or as I said, moving on to our next problem. We have select all expressions that are equivalent to this right here. As always, as I always would want you to do, is to rewrite the expression or equation. So negative 3.75 plus 2 parentheses, negative 4x plus 6.1. And you're like, but it's already there. If I can do it, you can do it. And I always do this, okay? So realize that what we have here is we have this positive 2 next to this parentheses. So that means we are going to distribute. So positive 2 times a negative 4x is a negative 8x. Positive 2 times a positive 6.1 is positive 12.2. And then I'm going to use the other ones in red, just why not? Negative 3.75 minus 3.25x. So now I'm going to use green, and we have this negative x and this negative 3.25. They're both negative. That means they're on the same team. If they're on the same team, they combine and they go together and add. 8, 9, 10, 11, that's going to be negative 11.25x. Well, looky there. There's one right there. And then what we're going to do is we're going to add, let me use blue, negative 375 and positive 12.2. So I'm actually going to write this one out. 12.2 and a negative 3.75. Well, there's a 0 there that's not there. So this is a 1, 12, carry over. That's 11, and that's 10. So that's 5, 11, 10, 9, 8, 7. That's 4. 11, 10, 9, 8. So that should be a positive 8.45. Now, if you look here, there's no positive 8.45. What did they do? They just left it alone. They left this negative 375 and this positive 12.2. That's okay. That is still a true expression. It's still true. Does positive 12.2 and negative 3.5 still equal 8.45? Yes, it does. So that is still true. We also have this right here. 11.25 is the same thing as 8 8x, negative 8x, and negative 3.25. So what they did is they added the blue, I'm sorry, not the blue, let me just put it in black. They added these right here and left it as 8.45, but also kept that the same, negative 8 and negative 3.25. So that is also true. And that's it. And I think that's the only true answer is going to be those two. So that is going to be, sorry, I'm just moving some papers over here because it's all over the place. That is going to be pretty much what we're looking at is B and D. All right, moving on to the next one. Here's a good one. Let's go orange. Enter the value of B when the expression 9x plus V is equivalent to this. Ooh, this is very interesting. So what they did is they said 9x plus B is the same thing as 3 times 3x plus 1. Well, here's the thing. How did they get this? Well, if you look at the original equation, they have this 3. What do you do with this 3? You multiply it here, and you multiply it there. So what's 3 times 3x? 9x. So 9x is there. What's 3 times 1? That's 3. So B is 3. Because that should be 9x plus 3 instead of B, because the 3 multiplies. Does that make sense? I hope so. All right, moving on. We got another example stem. I'm not going to go through all of them, but I'll go through some of them. What is equivalent to this? So we have 3x. This is nothing. So 3x plus 2, that the parentheses go away. We don't do anything. Then we're going to add negative 6x plus 3. The positive goes here. So it's 3x plus 2. I'm just bringing this down right here. That's a negative 6x because a positive and a negative is negative. Positive and positive here is still positive. So that's plus 3. And you're just going to add them up. So we have a negative 6 and a positive 3. That goes together. And that's going to be a negative 3x. Then we have a 2 and a 3. And that's going to be 5. So negative 3x plus 5. That is the correct answer. Moving on. Next one we have here is 2.1x plus 4.3. The parentheses, we don't really need to do anything there. Minus, then we have parentheses, negative 3x minus 7. Ha! I love this. So we have a negative here. We distribute this negative. We want everything in here negative, or the opposite, I should say. So negative is going to be a positive 3x, and a negative is going to be, let's circle them, a positive 7. And then we're just going to bring down everything else. Ooh, that's a 2. Oops. 2.1x plus 4.3. Add this with this. That should be 5.1x. And there's 5.1x there. But let's go to this one. We have 4.3, which is positive, and 7. So that's going to be plus 11.3. And that is going to be our answer. Positive 5.1x plus 11.3. Moving on to our next problem. All right. Oh, there's a lot of these ones. Okay, let's do some hard ones because you probably can get the easy ones. Let's do some hard ones. Enter the value of n. So, well, I don't know why I did that. Enter the value of n so that the expression negative y plus 5 plus 7y minus 9 is equivalent to ny minus 4. Okay, you're probably going to get confused on this one, all right? So we need to enter a value. We got to just read the instructions. Enter a value. So we have to find a value for n. So that negative y plus 5 plus 7y minus 9 is equal to ny minus 9. Now, we see ny. What do you think this n right here represents? Well, look right here. There's a 7 in front, right? So this represents a coefficient. It should represent a coefficient. Let's go ahead and solve a few of this. So it should be a number in front of the y minus 9. So that's what it should equal. All right, so let's try this out. Let's go ahead and reduce this and this down. So we have a negative y and a 7y. That should be 6y. And then we have 5. I should use pink. So we have 5 and negative 9, which will equal, oops, that's 4 right here. This is a 4. That's going to equal negative 4. So we have 6y minus 4. That's just ugly, but that's 6y minus 4. So what is this n going to equal? Well, the n represents the 6. That's the coefficient. So 6y minus the 4, because this is a 4. So the n represents 6. So that's the answer there. See, not that hard. Not that hard. Next one, select all the expressions equivalent to this. Okay, so negative 72x plus 60. When you get something like this and you see all of these numbers in front, that means they did distribution, but they took out instead of distributing in. They distributed out. They took out. So negative 72x plus 60. Sometimes I like these questions because they give you all the answers. So you can just try them all out and see if they're right. So we have negative 12 and 6. So first thing I'm going to try is negative 12 or just 12 in general. And the second number is going to be negative 6 or just 6 in general and see what makes sense. So if I take out a negative 12, what will that leave me here for this term? Well, I'm taking out, so I'm basically dividing by 12 because distributing is multiplying in, to take out is dividing. So 12, 24, 36, 48, 60, 72. I know my multiplication tables. 72 is a 6. And if you look right here, it is 6. They tell you it's 6, but that's just a double check. So that means I'm going to take out 12, and I'm going to take out a negative 12. If I take out a negative 12 from a negative 72, that means it should be negative 12. This will turn into a positive. So a positive 6x. But if I take out a negative 12 from a positive 60, that means that becomes a negative. So just to even work backwards, negative 12 times 6 gives me negative 72. And negative 12 times negative 5, well, negative and a negative turns into a positive, and that's 60. So I'm looking for something like this. Is there a negative 12 and a 6x minus 5? Yes. So A looks good. Let's make sure we double check that later. A looks good. B does not look good because there's two negatives right here. And that means that this number should be a positive, but it's not. So we're going to go ahead and say A is the correct answer. Now we're going to go try negative 6. All right, so let's go ahead and try negative 6 now. Negative 72x plus 60. We're going to take out a negative 6. And when I take out a negative, this will turn positive. This will be a 12x from this one because we're dividing. It's just the opposite. But it's positive. So negative 6, positive 12x. And this is a negative 6, right? And that needs to be a negative, and that's going to be a 10. So that should be negative 10. As we have a negative 6, 12x plus 10. So here's the thing. We have a negative 6, but it's a negative 12, so it's not that one. So we need to try a positive 6 now. So now we're going to try a positive 6. So it's not D. We know it's A. We know it's not B. Now we have to test to see if it is C. So negative 72x plus 60. We're going to take out a positive 6. We're going to take that out here, take that out there. And then it's 6. So if our 6 is on the outside, what should go inside? Well, it's a negative. So we know it's going to be a negative 12x. And this will be a positive 10. Does that work? That does work. So it looks like this is going to be the correct answer. And you can always double check it. 6 times 12 is negative 72. 6 times 10 is positive 60. That's exactly what we have there. And we're moving on. All right. Oh, I'll just check the time real quick. I feel like I've been going forever. 15 minutes. It hasn't been that long. All right. Moving on to the next one. So This one looks hard. We did that one. I think you can get this one. This right here is the same thing. The 3 is on the outside on the right. It's just the same thing as it means on the inside. You just got to figure out what that pretty much is. And to be honest, it may seem confusing. Again, it seems confusing. So like 3n plus 5, right? Well, what does that equal to n plus p? And the 3 is on that side. There's no difference. There's literally no difference. That means this is the same as this. The n is the same as the n. And the 3 being on the left is the same thing as the 3 being on the right. That's like saying 3 times 2 and 2 times 3 is not the same. That's exactly the same. So everything inside is the same. So this one's going to be 5. All right. Moving on, I think. I don't know. This one's probably tough too. I'm just going to go through all of these probably. All right. I'm chewing gum. I'm going to take it out because I probably chewing in the mic, and I'm really sorry. I just realized that now. And you're probably like, yes, thank you, Mr. Trochet. My goodness. I'm so sorry. This needs to be equivalent to P5 minus 2N. All right. So when you have these comparisons where they need to equal each other, you got to look at what is inside the parentheses and what matches. All right. So what I see first is that this 5 and this 5 can be the same thing if I got rid of this, right? So how would I get rid of this 6 at the bottom? Well, what I would do is I would probably take out that 6 at the bottom. So that means I'm taking out the denominator. So how do I take out a denominator? Well, we're not eliminating the denominator. We're just taking it out. And when we take out, we divide, right? So I need to divide by 1/6 because 1/6 is my 6 as a denominator with whatever's on top. All right. So 6 is at the denominator. So we're going to take out 1/6. So let me rewrite this again. 5, 6, and 1/3 n. And what I'm going to do is I have to make parentheses, and I need to take out, and I'm dividing, right? I take out 1/6. So if I take out 1/6, and these are 5, 6, I take out this 1/6 here. So I'm taking out 1/6. So that means 1/6 times 5 is 5/6. That's all I'm doing. But how do I get 1/3? That's a little tricky. So what would this equal? Well, here the funny thing is it kind of tells us right here, 2n. Does that make sense? What is 2n times 1/6? And you can just double check. 2 over 1 times 1/6 equals 2/6. And that equals 1/3. So that's equal. So that means that's 2n. So what does P represent? P is in the front. P is going to be 1/6. Again, when you take out, you are dividing in distribution. When you distribute inside, you are multiplying. So it's just the reverse. So P is going to equal 1/6. Moving on. All right. I've just got to make it fun sometimes for me. So sometimes it's more about me making it last longer. In terms of it's 6:28, and I'm trying to get this going. Make sure we're looking good here. Okay. This one I think you can do. This one is just decimals, but it's still the same concept. It's just a little bit trickier, but just know it's the same thing. You are taking away. Again, same thing. You have a 4.7 here. So if you 4.7 that in and 4.7 that in, you will find what B is. Moving on. And select all the equation that's in, then you can simplify that. Moving on. I mean, these are whole numbers. I guess I can do the decimals for you if you really want to, but 0.75x plus 0.25 parentheses x plus 12.4 and parentheses plus x minus 2.1. All right, I'm going to add up all of my x's. There's some x's here. This right here is distributed, so that's 0.25x. I'm going to add that. That gives me 1x. And then there's another x here. It's a positive, so everything stays the same. So that's going to be another x. So that's going to be 2x's. There's 2x's here. There's some 2x's here as well. So those are still in the balance because it's select all expressions. And then I'm going to add, so we have a quarter of 12.4. So we have to distribute there. I know I went a little fast. I really am sorry about that. But just know I just added all my x's together. All right, so let's try it one more time. 0.75x plus 0.25x, parentheses, plus 12.4 plus x minus 2.1. All right, 0.75 plus 0.25x plus what is this times that? You know, that's 0.25x. So 12, so that's I'm going to just say 124 divided by 4 because that's a quarter. That's 3, and then that is 1, so 3.1. So this is 3.1. I just pretended there wasn't a decimal there, and I just moved it in. All right, 3.1 plus x minus 2.1. So I should have a 3.1 and a negative 2.1. So we know that the 2x's here is good. That equals 1.0. This equals 1x right here plus another x. So that's going to be 2x plus 1. So that's A. It's not B. There's 2x's. That equals 5.2. So that's wrong. And then this one is the correct answer. So A and D. A and D. Moving on. Okay. We're on cluster B now, so it's going to be a little different. Enter the value of this. It looks like you're just going to do 5 times 13.5 minus 4.5. Do parentheses first. So that means that's going to be 8, 9, 9. 9 times 5, which is 45. Moving on. Do the parentheses first. Select all the expressions that are equivalent. So select all. That means there can be multiple. What is this equal? I think that's 1/8. So that's going to be 2.3 times 1 and 1/4, because I think 1/8 is 0.125 times 8, 40, 8, 16, 20, 8, 19. Yep. So that's 1/8. So basically it's saying 1 and 1/8 plus 1/8. And so that's 1 and 2/8, which is 1 and 1/4, minus 9. 1 and 1/4 is that, so that looks good. So 2/3 times 1.25, that is 1.25 minus 9. So A is the correct answer. The thing is, the 9 is negative. This is a negative 9, but here they put it in front. So that's an easy elimination. That is an easy elimination. Again, another negative 9, that's good. You can move the negative 9 in front. So negative 9 plus 2.3 and 1.25. That's fine. 1 and 1.25 plus 1/8, that is 1 1/4, because it is 1 and 2/5. And 1 and 1/8 is 1 and 125. So 1 and 1/8 does equal 1.0. Oh, sorry, 1.125. That is what 1/8 is here. Add the 1 in front there, and you're good. So then, yes, C looks good to me. So again, don't get tricked by this negative 9. You're like, there's no negative 9 there. This subtracting 9 is negative 9, basically. And then the 9's in the parentheses, that is completely wrong. So it's going to be A and C. Moving on. All right. Oh, look at this. What is the mean? Mean. You need to add everything up. Negative 15 plus negative 12 plus 8 plus 9. 9 and 8, 17. 15 and 12 is 27. Negative. Positive, that should be negative 10. We have 1, 2, 3, 4. 10 divided by 4. That, oops, excuse me one second. That should be negative 10 divided by 4, which is going to be, let's see, negative 5 halves. And negative 5 halves is negative 2.5 for the mean, which is the average. Moving on. Javier's fuel tank holds 12 and 3/4, not 2 and 3/4. 12 and 3/4 gallons of gasoline when completely full. He had some gas in the tank. He added 10.3 to be. So how many gallons were in the tank before he added some? So we have 12.75. You need to convert. And then we added 10.3. So if I take away 10.3, This will tell me what I had remaining. So 5, 7, 6, 5, 4, and 2. So I had 2.45 gallons remaining. 2.45 gallons. Moving on. All right. Okay. All right. A coach buys a uniform and a basketball for each of the 15 players on the team. It sounds like it's to be expensive. Basketball costs $9.40. Yeah, good luck finding that price. $9.40 for a basketball, like a nice one? That's something more like a Nerf basketball. The coach spends a total of $420 for uniforms and basketball. Enter an equation. So we don't have to solve. We just have to enter an equation. That models the situation with U, and U is the uniforms. Okay, so we have 420 is the total. So 420 equals the uniforms and basketball. So uniforms plus basketballs. Now, we do know something. We know that basketballs cost $9.40 per basketball. So we're going to go ahead and put $420 equals U plus $9.40. You can have the zero if you want. You don't have to. B. And you can write it this way too. $420 equals $9.40 B plus U. You can even write it 9.4 B plus U equals $420. That way. That is going to be your answer. And moving on. All right. Second stem, another thing. Coach buys uniform. Each player, 15 players on the team. Each basketball costs $9. Coaches enter the cost of one. Oh, the cost of one uniform. Okay, so the equation is correct. The equation is correct. So let me just, 420 equals 9.40, right? 9.40 B plus U. The cost of one uniform would be what? And by the way, I hate when I go too fast sometimes because I'm just kind of looking at the clock, and that's my own fault. 27 minutes in. We're going to pause real quick, and I apologize. So we have to understand a few things. One, we need to enter an equation with U that models U. So we need to have U equals, okay? U needs to be part of the model. U needs to be kind of what it is, but there needs to be, the 15 players is also a factor. So we might need to find out what U is, but here's the thing. We have 420. There is 15 players on the team, right? Each player gets a uniform and also gets a basketball that costs $9.40. I'm going to pause real quick because I think I'm a little tired. I'm going to pause real quick. Took a quick breath, and we're coming back. So we know that 15, there's uniforms, so there's 15 players. So 15 players get a uniform. 15 players also get a basketball, and we know the price of the basketball, which is going to be $9.40 B. So this is our equation. Now, I would write this first, and then if you needed to find out what U equals, then you can find out. But it says enter an equation that models the situation with you. It has to be with you, not solve for you in a sense. So I would say 420 equals 15U plus, and then you can do a 15 times 9.4B, or you can leave it like this. But 15 times 9.4, I'm not going to do that math. This is actually the correct answer. The other way is just a little bit more complicated. And no, we don't even need B. B is the price of the basketball. So each basketball costs, I don't know why I said 9.4 B. Excuse me. I apologize. I really do. 9.4 is the price of the basketball. We don't need the variable because we already know the price. We just don't know the price of the uniforms. 420 equals 15U plus 9.4. I might have to cut this out. All right. I'm going to do this problem over again. Hopefully I cut this out. Okay. Now we're going to do this one. I had to cut out the last one, so we're going to do this one. We have a coach buys a uniform and a basketball for each player, 15 players on the team, okay? Each basketball costs $9.40. The coach spends $4.20. in total for the price of the basketballs. For the uniforms and basketballs. U is the cost of one uniform, okay? So now we know that the total is $420. That equals 15 players on the team, and each person gets a basketball and a uniform. So 15 players on the team. We already know that each player is going to get a uniform and a basketball. Let's just say it's B. U is the cost of one uniform. They don't tell us U, but they do tell us the cost of the basketball, which is $940. And there's going to be 15 players that each get one. So 15 uniforms and 15 basketballs. So 420 equals 15U plus B, 15B, and we know what B is. B is 9.40. That is your equation that you need to write. All right, moving on. All right, why is this? Oh, there we go. Jenny has $25 and she earns $10 for each lawn that she mows. Jenny wants to buy a concert ticket that costs $65. Enter the minimum number of lawns Jenny needs to mow to be able to buy the concert ticket. Okay, so the concert costs $65. That's my total. I want my lawn mowing business, I want that to be equal or above 65. So let's just say the minimum I need to buy, so I need to equal $65. I have $25. So this is my starting point, right? This is what I start with. I start with $25 and get $10 for each lawn. So I get $10 times for each lawn mowed, and I'm going to say that's X, okay? X equals number of lawns mowed, okay? Number of lawns mowed. So how am I going to do this? I'm going to minus 25 from both sides. And then I'm going to get a different color because I like green and blue. So that's 0.654, that crosses out, equals 10x. So I need to divide by 10, divide by 10. So that's 4 equals x. X is the number of lawns. So enter the minimum number of lawns, 4. That's it, 4. Yeah. So yes, if it was like, for example, 4.2 lawns, then you'd have to round up and go 5 lawns. Because you can't, can you imagine going to someone's house and saying like, hey, can I mow like half of your lawn? They'd be like, no. All right, moving on. Drag the correct arrow onto the number line to represent the solution inequality. Okay, so we have 6x minus 4. This is less than, so this is less than. This is greater. All right, that's greater than. So 6x minus 4 is less than 8. You do the same thing in solving. So I'm going to add 4 to both sides. All right, that's going to be a 12. This cancels out. So we have 6x is less than 12. So x divided by 6 is less than 2. X is less than 2. Now, remember, we have less, we have greater, less and greater, this and this. Then we have less than, or equal, or greater than, or equal. Less than is this, but then the equal is underneath. And then we have the greater than or equal to. When we have, I'm going to use black, when we have the less than, it's open circle, and greater than, it's open circle. Why is it open? Because it can't equal that. So it can't equal that. When it can equal it, you put a solid dot. Solid dot, like that is the point that it equals, and then the arrow will tell us where to go next. So x is less than 2. So I need to go to 2. It's less than. That means I open circle. And where is x less than 2? Well, x is less than 2 here. Here's all the less than 2's. All right. So that means you're going to use this one right here and place it right on top. Excuse me. Moving on. All right, next one. Marcus has a pool that can hold a maximum of 4,500 gallons of water. Pool only contains 1,500. So it already has this as my starting point. Marcus begins to add more water at a rate of 30 gallons per minute. 30 gallons per minute, and it says the number of minutes is M, 30 gallons per minute. Marcus can continue to add water to the pool without exceeding the maximum. Okay, this is the word maximum. So it has to be at 4,500 or less than. If it goes over then, well, it can't hold it, and it's just going to overflow. So we are going to say that this number, this side has to be, this right here is less than, this is the bigger mouth, right? This is the alligator mouth. So this is the bigger side. So this means that this side has to be less than 4,500. If this side is more, then it's going to overflow. It's going to just be like overflowing, just all this nonsense. So that's why this small side is on this side. So the smaller side, the big side is on the wider side. Moving on to this, minus 1,500, minus 1,500. That's a 0. 3,000 has to be greater than or equal to 30M. Divide by 30, divide by 30. You cross out the zeros. The 3 becomes a 1. So that is going to be 100. So 100 M. Now, quick tip. You like having the variable on the left side. It makes it easier to read. So M can be less than or can be equal to 100. And you just got to keep the same mouth on the 100. So here's the mouth. The mouth is still on the 100. And here's my alligator. Oh, that's a pretty good alligator. Oh, wow. I'm so good. M is less than or equal to 100. So enter an inequality. Here's the inequality. M is less than or equal to 100. If it's more than 100, it overflows. Hence that picture. Moving on. All right. Come on. What's going on? There we go. Clear. Okay. Linda has $26. She wants to buy a ski pass for $80. She can earn $6 an hour per babysitting. Enter an inequality. Okay, inequality is this is greater than, right? This is less than, right? This is less than, this sign right here. And this is greater than or equal to. This is less than or equal to. So she has $26. She wants to buy a ski pass for $80. So if I want to buy a ski pass for $80, I'm happy to make more than $80. So whatever this side is, actually, if you want to, you can say that $80 is the total and you want to make greater than. This is greater than $80. So then you can put it on this side. She can earn $6 an hour babysit. H is hours, so $6 an hour, but she has 26. So $6 per hour is that. She has 26 is that. And then that's going to be my total of 80. Minus 26 on both sides. That is going to be 8, 7, 6, 5, 54. And 6H divided by 6 divided by 6. That looks like 8. Nope. 8 is 48. 9. 9, 18, 57, 65, 54. Yep, 9. H can be greater than or equal to 9. All right, so she can work 9 or more hours to make enough money to at least is a key word for inequalities, at least, so no more than in high school. H is greater than or equal to 9. All right, moving on. All right, so when you get something like this and it says the number line, you need to solve. So negative 3x minus 5 is less than negative 2. Add 5 to both sides because they cancel. And then that's going to be a 3, negative 3x. You divide by negative 3. Here's a big important tip. When you divide by a negative, you have to flip. You have to flip. I can explain it to you why you need to flip, but at this moment in the year, we're just going to say you flip it. I can easily explain why. I can prove it to you. I can do with test numbers. That can take a whole hour, though. I'm not going to do that. When you divide, you need to flip this. So x is going to be greater than negative 1 because 3 divided by negative 3 is negative 1. So x is greater than, so here's the greater side. So this is good, not these. These are less than sides. And greater than, and this is a full dot. We don't want that because there is no equal sign. So it's got to be A. It's got to be A. It's got to be A. Moving on, I think this is our last one. Yes. All right. So which of the number line shows, oh, that's it. Oh, here's the example stem. So give me a second. Oh, oops. Oh, oops. There we go. This is the example stem. Here we go. One more time. 3x plus 7 is greater than 13. Minus 7 on both sides. Cross out. 3x is greater than, that looks like 6 divided by 3. X is greater than 2. So there's no line underneath. So I don't need this guy and I don't need this guy. And then I don't have the greater than. So this is greater than, this is less than. So I'm going to put this on the 2. And then you're done. Mic drop, pen drop, all that good stuff. 41 minutes. I am so sorry. But these are some things that you need to know. So I hope you all did well. Thanks for following along. Sorry it took so long, but I'll do what I can. I'll do whatever I can. I hope you succeed. It's been a heck of a year, everyone. If you've watched this entire video, then you're a real one. It is 6:51 right here, May 5th. It is Cinco de Mayo, not Mexican Independence Day. Don't say that. But I just want to say thank you. It's been a heck of a year. I'll do whatever it takes for you to succeed. And I'm sorry if you didn't feel very successful this year during distance learning. It is what it is. Have a great day.